Combining functions. Sometimes we need to combine functions, and functions can be added, subtracted, multiplied, and divided. And sometimes we also need to plug one entire function into another function. This first example says for the indicated functions f and g, find the functions f plus g, f minus g, f times g, and f divided by g. Your book also says to find the domains, but you don't have to do that. So we're going to start with f plus g. That just means we combine like terms. It would be the f function, 3x plus 1, plus the g function, x squared plus 4. And when we combine like terms, we would have x squared plus 3x plus 5. The subtraction, f minus g, you have to be careful not to mess your signs up. I would write the f and then minus, then in parentheses, the g. That will help you remember that the subtraction goes to all the terms, to the x squared and to the 4. So it would be 3x plus 1 minus x squared minus 4, and combined like terms would be negative x squared plus 3x minus 3. Now multiply f times g. So 3x plus 1 times x squared plus 4, and you're going to FOIL that. You would have 3x cubed plus 12x plus x squared plus 4. There aren't any terms to combine there, so you can just leave it right there, or you can rearrange it. You could swap the 12x and the x squared so that it's in order from largest exponent to smallest. It doesn't matter. And then lastly, the division, f divided by g. You'll just write the f function over the g function. Sometimes we want to evaluate a function for a given value of x. So we have two different functions, one for f, one for g. And the first example wants us to find f of negative 6. So to find f of negative 6, you use the f function and just replace all x's with a negative 6. 2 times negative 6 plus 3 would be negative 12 plus 3, which is negative 9. Now the second one is a double, and you always work with these from right to left. So first we're going to plug the negative 6 into the f function, work that out, take that result and plug it into the f function again. Now we already found f of negative 6 just now, and it was negative 9. So now I plug negative 9 into the f function. 2 times negative 9 plus 3 would be negative 18 plus 3, which is negative 15. The third one is read f of g of negative 8. And again, you're going to work right to left. You'll plug negative 8 into the g function, work that out, take that result, plug it into the f function. So starting with g of negative 8 into the g function, it would be 4 plus negative 8 squared, which is 4 plus 64, 68. Now the 68 goes into the f function. 2 times 68 plus 3 comes out to be 139. When we're plugging an entire function into another function, which is called composition of functions, there's a couple of different notations. You might have f with this little circle, g, and that's read f of g, or you might have the parentheses, and that's read f of g of x. But both of these indicate that the function on the right will be replacing all of the x's in the function on the left. So it says for the indicated functions f and g, find the functions f of g and g of f. Again, ignore the instructions to find their domains, and then we're also not going to do f of f and g of g. We'll start with f of g, and the function on the right plugs into the function on the left. So 2x plus 3 is going to replace the x in the f function. I still have absolute value, but where the x is, I put 2x plus 3, and then I still have plus 1 and close the absolute value. And then inside, combining like terms, 2x plus 4. Now going the other way around, g of f, the one on the right always goes into the one on the left. So absolute value in everything goes into the g function where we see an x. That will be 2, absolute value of x plus 1, and then plus 3. You just have to leave it there. You can't distribute the 2 into absolute value bars. Okay, same instructions. This time f of x is x plus 2, g of x is 1 over x. So f of g, the one on the right, plugs into the one on the left. The 1 over x goes where the x was in the f function. And then the other way around, g of f, f plugs into g. So I still have 1 over, and then where the x is, I replace it with x plus 2, which is the f function. Same instructions, f of x is the square root of 4 minus x, g of x is x squared. So f of g, the one on the right, goes into the one on the left. So it's the square root of 4 minus, and where I have an x, I replace it with x squared, the g function. And then that's as far as that one will go. Just a side note, a common mistake is to write this as 2 minus x, because it seems like since 4 and x squared are perfect squares, you should just be able to take the square root of each one. You can't do that because of the subtraction, or you wouldn't be able to do it if there was an add there either. So be careful about that. Square root of 4 minus x squared is as far as that one can go. And then we have g of f. F plugs into g. So where the x is, I replace it with 4 minus x, and then it's all still squared. Now that squared and square root will cancel each other out, and you're left with 4 minus x. Sometimes we're given the composition. We're given what happens when the two functions are plugged into each other, and then we're asked to figure out the original two functions. And this is a skill we have to use in calculus quite a bit. So h of x is the result of already doing f of g. We have to figure out what was the original f and what was the original g. The easiest way to do this is have g be what's trapped inside something. So for this first example, 2x minus 7 is trapped inside the parentheses. And then f will be what you would have if you can... F would be what you would have if you replaced the 2x minus 7 with just an x and kept everything else. So whatever g is, remove that, put an x there, and that's what f is. So then the last one, the inside function, would be 4 plus 2x. And then f would be the square root of, and then you just put an x where the 4 plus 2x used to be.